So, have you looked into how we can optimize our caching strategy for the new API updates? I think there's a lot we could do with distributed caches.
Yeah, I've been reading up on it. The challenge seems to be keeping all the nodes in sync without too much overhead.
Absolutely. Consistency is key. But let's not forget about performance. We need to make sure that reads are fast and writes don't bottleneck everything. What do you think about using a consistent hashing mechanism?
It sounds like a good idea. It should help distribute the load evenly across different cache nodes.
Exactly. And we might want to consider implementing an LRU, least recently used, eviction policy to manage memory usage efficiently. Plus, we could add some sort of time to live, TTL, settings so data doesn't get stale.
That would definitely help with maintaining fresh data while keeping performance up.
Oh, and speaking of performance, did you know that sometimes just changing the order of operations can shave off milliseconds? Like, if you prefetch certain resources before they're actually needed. It's like being a bit psychic with your code.
That does sound interesting. Prefetching could save quite a bit of time if done right.
For sure. Now, imagine if we also implemented a hybrid caching approach where frequently accessed data is stored in memory, and less critical stuff goes into disk-based storage. Could really balance out the speed and cost issues.
A hybrid approach would probably give us the best of both worlds.
You got it! Also, let's talk about monitoring and logging. We need real-time stats on hit rates and miss rates. Maybe integrate something like Prometheus or Grafana to visualize this data effectively.
Visualizing those metrics would definitely help us tweak the system as needed.
Definitely. And hey, remember when we tried that crazy idea last year with the custom middleware? Speaking of which, have you thought about how we'll handle cache invalidation for the frequently updated data? That's always been a tricky part.
Yeah, it can be tough. We need to make sure the cache stays up to date without overwhelming the system. Wow.
True. What? One approach could be using versioning. Each piece of data gets a version number that increments every time it changes. Then, clients check their local copy against the server version.
Versioning sounds like it could work well to keep things synchronized.
Absolutely. Another method is event-driven invalidation. When data changes, publish an event to invalidate the relevant cache entries across all nodes.
Event-driven invalidation would definitely help ensure consistency.
Right. And let's not forget about TTLs here too. Setting appropriate expiration times can prevent stale data from hanging around indefinitely. Of course, choosing the right TTL value is crucial. It needs to balance freshness with performance costs.
Finding that sweet spot for tells will be important.
Agreed. Also, what do you think about using a combination of push and pull strategies? Push notifications when there are updates and periodic pulls to double-check everything is current.
Combining both strategies could provide robustness and reliability.
Exactly. Now, if we implement these techniques effectively, we should see significant improvements in both performance and data accuracy. Speaking of ensuring data accuracy, have you given any thought to the consistency models we should use in our cache implementations?
Yeah, it's definitely something we need to nail down. Strong consistency would be ideal, but it might come with performance trade-offs.
True. Strong consistency guarantees that all reads return the most recent write, but it can introduce latency due to synchronization overhead. We might want to consider eventual consistency for parts of the system where strong consistency isn't strictly necessary.
Eventual consistency could help balance performance and correctness.
Exactly. With eventual consistency, we allow for temporary inconsistencies that eventually resolve themselves. This model works well for read-heavy workloads where some staleness is acceptable.
That makes sense, especially for less critical data.
And then there's causal consistency, which ensures that transactions are ordered based on causality. It's a bit more complex but can provide better guarantees than eventual consistency while still offering good performance.
Causal consistency sounds like a good compromise between strong and eventual consistency.
Absolutely. Implementing causal consistency involves tracking dependencies between updates, which adds some complexity but ensures that related updates are processed in order. We could use vector clocks or logical timestamps to achieve this.
Using vector clocks or timestamps would help maintain the right order of updates.
Definitely. So, depending on the specific requirements of different parts of our system, we might end up using a mix of these models. What do you think about adopting a hybrid approach where we apply strong consistency to critical sections and rely on eventual or causal consistency elsewhere? Speaking of different approaches, have you considered the pros and cons of memory-based versus disk-based caching solutions?
Yeah, it's a big decision. Memory-based caching is faster but limited by available RAM.
Exactly. Memory-based caching is great for high-speed access since it operates entirely in RAM data. It's super fast for reads and writes, which is perfect for frequently accessed data. However, it comes with the limitation of being constrained by the amount of RAM available.
That's true. Disk-based caching could offer more storage capacity at the cost of slower access times.
Absolutely. Disk-based caching leverages hard drives or SSDs to store larger amounts of data. It's slower compared to memory-based caching because disk I/O operations take longer. But it can handle much larger datasets, and is useful for scenarios where not all data needs to be accessed instantly.
The trade-off between speed and storage size is pretty clear.
Right. And combining both approaches can be effective. Use memory-based caching for hot data that needs rapid access, and disk-based caching for less frequently accessed, but still important data.
A hybrid approach like that could optimize both performance and storage efficiency.
Definitely. We need to carefully monitor and adjust the sizes of each cache pool based on actual usage patterns. What do you think about setting up some initial benchmarks to determine how much data fits into memory versus what needs to go on disk?